Hey mathematicians, Miss Sawyer here. Today we're going to start by making a foldable like this. If you were in Algebra 1 last year and you were with us through the whole year, you might remember making one like this, these open and close with some notes on the inside. If you were very organized, it's possible you might still even have this in your notes. So in a second, I'm going to ask you to pause this video and get your materials. If you still have this from last year, grab this. That will save you a lot of time. You'll just have to add some extra things to it. If you don't have this from last year, you need a scissor, something to write with, and a piece of paper. So right now, pause your video and get your supplies and then come back and be ready to start. All right, so what we're going to be doing is making a foldable with GERMDAS. And some of you might recognize part of this, but you maybe learned PEMDAS. That's okay. This is very similar, but we use something a little bit different because we have a lot of grouping symbols that we'll be using in Algebra 1.2. And so we don't just use PEMDAS because that P stands for parentheses. We use G for grouping symbols because we use a lot of grouping symbols in Algebra 1.2. So what you're going to do is start by folding your paper in half the long way. Some people say the hot dog way. So you're going to fold it in half the long way like this. So you have a long, thin piece. And then we need 4 sections here. Since it's an even number, that's easy for us to do by figuring out half and then cutting each one of those in half again. When I do that, I want to make sure I leave this back part whole. I'm not going to cut this at all, okay? So I'm going to fold my paper in half so that I can just see where my halfway mark is. And so when I open up to cut, I don't want to cut this back part. So I'm just going to be cutting through one layer so that it kind of opens like a flap here, but this piece is still a whole piece that's not cut at all. And then I want to go halfway between each one of these. And if you want to be really precise, you could fold it again. I'm just going to kind of estimate and get it about halfway. Okay, so now you should have 4 little flaps that you can lift and a flat part on the bottom. So we're going to start by talking about GERMDAS. GERMDAS is what we'll be using when we talk about order of operations in algebra. So the first letter here is G. And so on your first tab, you're going to write a G. And when you open it up, we're going to be writing some information in that tab. So if you made this last year and you were able to find this, you should be able to just add to it if there's anything you need. So the G stands for grouping symbols. So make sure you're writing what I'm writing. Should be writing grouping symbols here. And the grouping symbols we're going to be using are parentheses. So if you learned PEMDAS, that's what the P stands for. But we also will use a few others. We'll use these brackets, this absolute value symbol, and this long dividing symbol. It kind of looks like a fraction line, but it tells us to divide. If you need to pause here, pause and write all of these down. Otherwise, we're going to be moving on to the next spot. The next spot is the E and the R. And above the E and the R, I want you to draw an arrow that's moving from left to right. Okay. E and R stands for exponents and radicals. So when I open that one up, I'm going to be writing under the exponents and radicals spot. And some examples of exponents would be when we use a number to a power, for example, 3 to the 4th power or 2 to the 3rd power. That shows us an exponent. A radical you've probably seen before as well. That's this little symbol. Like this is the radical of 9 would mean what times itself would give me 9. So 3 times 3 would give me 9. Or what times itself would give me 25. So these are the radicals. And I want you to make a little note here that says left to right. when we solve in a multi-step problem, we always are going to move left to right. So that's what that little arrow means up here. So make a little arrow down here showing you left to right. Okay, pause here if you need to copy that down, or if you're a fast writer, we're going to move on to the next tab, which is MD. And again, we're moving left to right here, so we're going to draw a little arrow up here. And MD stands for multiply and divide. So under that tab, we're going to write multiply and divide. And again, for multiply and divide, we move left to right. So that can sometimes be a little confusing. Sometimes it looks like you have to multiply first all the time. That's not always true. If a division problem comes to the left, you would do that first. So multiply looks like maybe the dot, like 3 times 3, or you might see the multiply symbol like 3 times 3 like that, or it could even look like parentheses. And divide could be like the usual divide symbol we see, or it could even be that long fraction line. Pause here if you need to copy it down. If you're with me, we're going on to the next tab, which is AS. And we're going to do an arrow on top of that as well. And AS stands for add and subtract. And add looks like 2 plus 6. Subtract would look like 6 minus 10. And just like the others, we're going to move left to right. Okay. So we're going to use this when we do order of operations problems. And if you have this with you, you can use this even on your spiraled quick checks and your test. So keep this somewhere for now. When you get to school, we'll show you where to put it in your binder, in your notes. But keep this with you because you can use this for any order of operations problems we do when we're taking tests and quizzes in class. We're going to do a quick practice problem on the back. That will be a reminder for you as you're working through this, okay? So just flip your paper over, and I want you to write down this problem. So it's going to look like 6 plus the absolute value of -7. So make sure these look like absolute value signs, not a 1. They're kind of longer. Times 33 minus 30. And we're going to do a long dividing bar here, that long fraction bar, over the square root of 9. Okay? So this looks like a really complicated problem. We've got lots of grouping symbols, we've got adding and multiplying, but we're going to use our notes here to work through this, okay? So the first thing we have is grouping symbols, okay? Remember, grouping symbols could look like any of these things. So as I look through this problem, I see that I have an absolute value sign, I see that I have parentheses, and I see that I have this long dividing fraction line. So I'm going to move left to right. The first thing I see here is this absolute value of -7. So if you remember, the absolute value means the distance from 0. An absolute value is always positive because it just means the steps away from 0 you are, or the distance from 0. So if I had a number line, -7 would be 7 spaces from 0. So I'm going to rewrite my problem. 6 plus 7, the absolute value of -7 is 7, times, and then I still have these grouping symbols, so we'll get to those next. 33 minus 30 over, so the numerator and then my denominator is going to be this radical, this square root of 9. Okay? So as I'm moving left to right, then I'm going to work on my next parentheses here. 33 minus 30. So I know 33 minus 30 gives me 3. So then I'm going to rewrite 6 plus 7 times 3. And I don't need these parentheses anymore because I have only one term. So I can drop my parentheses with this long dividing line over the square root of 9. Okay, so I'm almost done with my grouping symbols. But I notice that this long dividing line is a grouping symbol. However, I can't solve this until I get my top and my bottom down to one number. I can't divide when I still have multiple steps here. So I'm going to ignore this long line for just a minute, and I'm going to move on to my next step, which is exponents and radicals. So I don't see any exponents. I don't have any like this in my problem, but I do have radical. So now I'm going to solve for this radical. So I could use a calculator to do this, or we can think in our head, what times itself would give me 9? And I know that 3 times 3 is 9. So now I'm going to rewrite my problem. And I'm going to put 3 here because I know that 3 times 3 gives me 9. Okay, now I have no more exponents or radicals. So I'm going to move on to the next, which is multiply and divide. So I'm going to move left to right. I don't see any dividing signs up on top, but I do see this multiply. So that's what I'm going to do next. So I'm going to write 6 plus, oops, you guys, I just noticed I did something silly. I should have written a 7 up here, and I wrote a 3. So let's change this over. I'm sorry, that's confusing. That should have been a 7 right here, and for some reason I copied it over as a 3. So I have 6 plus 7 times 3. So 6 plus 7 times 3. So what is 7 times 3? If you want, you can use a calculator, or if you can do that in your head, 7 times 3 is 21. So I'm going to write that next. And then this whole thing is going to be divided by 3. Now I still can't quite divide that yet because I don't know what this is yet. So I'm going to go next in my chart. I have add and subtract. So now I can add and subtract. What is 6 plus 21? And I get 27 divided by 3. Now that I have one term on top as my numerator and one term on the bottom as my denominator, now I can actually solve this. So 27 divided by 3 is 9. I'm going to put a little box around my final answer, or you could put a circle around it. There's a lot of steps here, so sometimes it's just easier if you can see that you got to your final answer. Remember, you can keep this and use this on your tests and quizzes, so bring this to class the next time you come, and we'll put it in our binders, and then you can use it throughout the whole trimester of Algebra 1.2.